Hello everyone, welcome to our Inferyx webinar today, Spotting Insurance Fraud with AI and Knowledge Graph. Let me introduce you to a speaker today, Yogesh Palrecha, the founder and CEO of Inferyx. Imran Khan, Chief Analytics Advisor of Inferyx. So over to you, gentlemen.
Thank you, Sarah. Good morning, good afternoon. Hi, this is Yogesh Palrecha. I'm the founder and CEO of Inferyx. Today I'll be talking about how to leverage AI, machine learning, and knowledge graph for building systems for fraud detection and prevention in the insurance domain. Just to give a quick background about myself, I have been in industry for almost 22 years, specialized in fraud detection solutions for banking and the insurance world. Let me hand over to my colleague here, Arslan Khan, who will be introducing himself, and then we can start the webinar.
Folks, good morning, good afternoon, wherever you are. My name is Arslan Khan. I'm the Chief Analytics Advisor for Inferyx. A recent induction into the board, and very happy to be here. Just a quick background. I am a data science and analytics leader. I have helped various organizations in financial services, both banking and insurance, in building data science and analytics techniques for better managing risk, which includes fraud risk, operational risk, and all the various facets of it. Happy to be here. I'm going to be talking about some of the more fraud framework type of areas, and then what the pitfalls are of where we are and then where we need to go. And then Yogesh is going to be doing more of the technical conversation around it and what the capabilities are of utilizing AI and ML in fraud detection, and then most importantly, fraud prevention.
Thank you, Arslan. So moving on, just to talk about a bit about the Inferyx. So as I mentioned, we are a global analytics company, and we are a team of data scientists, data engineers, and fraud specialists. Where like myself and Arslan comes with a background in the risk in the fraud space. I'm more pitching in from a technology perspective. So we work with banking and insurance companies to understand their problems in the fraud space. And then kind of help them build solutions using our platform and services. So the agenda for today would be we'll take an overview of the insurance fraud. Where does the fraud? How is fraud within the insurance space? How deep it is and how it is impacting. Then we'll talk about the pitfalls in the way the fraud management frameworks are built today, and what are the modern ways of tackling those. We'll also talk about a bit on the technology front, like how technology can really enable the fraud prevention part, the fraud detection techniques, AI, and the knowledge graph overview. And then finally, if time permits, we'll also go for a live demo using our platform where we'll demonstrate, how an end-to-end an architecture can be implemented using for the fraud space.
So let's talk about fraud, right? And I'm sure most of you in attendance are fairly aware of these just high-level statistics on what fraud is and what the scope of it is. So it is a growing problem. In terms of scale, about $40 billion plus is lost due to insurance fraud, and we're talking about non-healthcare fraud here. And that really translates into a significant chunk per family. About $400 to $700 per household in the US is the increase in premium for each of the households because of that fraud. The key takeaway from this particular slide is, at the end of the day, fraudsters have become sophisticated over time. Now we don't have those legacy type of frauds where you would have a fraudster who would steal the identity of a person and then perpetuate fraud. Now we have fraudsters who are really dealing with a large scale. And what that means is we as organizations need to be at that same level of scale and scope. And we need to employ similar sophisticated technologies to catch these fraudsters, and then most importantly, to prevent fraud. So a quick overview of the types of insurance fraud, and I won't necessarily go into every single one of them, but these pretty much go from life to P&C to healthcare to you name it. But essentially, starting off at the beginning, there's that application fraud, right? Folks are misrepresenting the facts on the applications themselves. They're concealing and hiding certain data that would really change or impact their insurance and the coverage of it. Claims fraud around life, forging the death certificates, or just in general death fraud, for forgery of the beneficiaries on the life insurance policies as well. And then you come down, there's premium diversion, where the agent would fail to send the premium to the underwriter. And then you come down, there would be the workers' comp fraud. And then from the insurance companies, from our standpoint as well, there is this illegitimate denial fraud where sometimes our own workforce, our own agents, our own claims processing agents, due to various types of pressures, may end up denying legitimate fraud claims. So again, legitimate insurance claims. So at the end of the day, the types of insurance fraud are various. They keep growing because the fraudsters are becoming sophisticated. So we also need to become sophisticated as well. So when we look at the existing fraud management frameworks, they lack in a few different areas, right? Some of these areas are, the top one being that the management insurance companies is not necessarily fixated on fraud as an issue. Fraud is certainly brought up, it is discussed, but it's discussed as a siloed topic. It's considered an area that fraud specialists need to deal with, not necessarily an ongoing agenda item for management committee meetings. Then, in terms of the ongoing operations, fraud again over here is also considered as a separate topic, something that the fraud investigation teams are really concerned with. It's not necessarily part and parcel of the operational claims processing. And that's going to be something that we'll talk about, and Yogesh will kind of provide an example of how do you utilize AI and ML and incorporate that as a preventative control within the overall claims processing workflow. From a skill set standpoint, there is insufficient specialization. A lot of the fraud specialists or fraud investigators are really your typical claim handlers that are wearing multiple hats. So that's an area where investments need to be made to improve the specialization. In terms of the investigation methods, they also need to really be brought up to the current times. Right now, the investigative methods are fairly old school. Things have been done the same way for a number of years. And then the last 2 points, right? From a technology ecosystem standpoint, this is where significant investments need to be made in the technology ecosystem, in the data management and data strategy when it comes to fraud. At the end of the day, anything that's going to be considered emerging tech in our today's conversation, AI and ML, is dependent on data. So at the end of the day, we do need to have that maturity in the purpose-built data lakes or the tool setting that ends up helping us in detecting and preventing fraud. And then the last topic or the last point here is really the way these frameworks are built, they are fairly static and detective in nature. We need to fast forward, be more proactive about fraud, and make these controls dynamic controls and preventative controls. Some of the benefits of utilizing technology-enabled fraud prevention, I'll go through these rather quickly. At the end of the day, utilizing technology, utilizing data, artificial intelligence, machine learning, we can recognize the fraud patterns faster. Yogesh will talk about high level, what are some of these machine learning techniques, and some of these really help us in identifying patterns and anomalies, new strategies that are being built and that are being deployed by the fraudsters. We can find those out. We are trusted with the PII from our clients and customers, so we're able to better safeguard that PII utilizing these techniques. And then data from connected devices, right? From our smartphones to smart cars to IoT devices, we are in a much better position to gather that data and then utilize it to prevent fraud. The right level of technology tool set and the skill set can help in cyber fraud prevention, and online being a big distribution and sales channel these days. It's an important area. And then this helped in mitigation of losses. There is that angle of improving and making the fraud investigations efficient as well, utilizing technology. So again, it really this idea or this topic is self-fulfilling. I don't think anyone would disagree with these benefits. So those are the high-level benefits. And then, Yogesh, I'll invite you to kind of talk about some of these fraud detection techniques that can be applied utilizing these types of technologies.
Yeah. So I think from a technique perspective, I mean, there are some traditional techniques which leverages like statistical analysis. That is where, as an analyst, we start looking at the data. We try to understand the data, do a descriptive analytics, and then come up with thresholds so that we can build this rule-based models using a rule engine. But again, these rules are very static in nature, and all these thresholds have to be adjusted on a periodic basis. That involves a lot of manpower, and like in terms of building up the systems for specific tuning, etc. So I think there are a lot of limitations in the way traditionally fraud is being detected, which is like rule-based system. So in the more advanced world, what we can do is we can use machine learning, AI, knowledge graph, a combination of all three. I know like a lot of companies have already started leveraging machine learning and AI. Some of the companies are kind of experimenting with it. Some are running like in parallel in the production environment. But there are very few companies who have actually taken it all the way till the production, and that is where we our experience really comes in. So we have worked with the companies where we are really taking them from the traditional techniques to the advanced analytics techniques, which leverages AI and ML, and also a step beyond that. So there could be companies out there who are already doing AI and ML algorithms, but then how to really take your journey to the next step. And we feel that knowledge graph really comes to the rescue here, where it can bring in additional features to your existing models, or even your existing rule-based system, which can improve the predictability of the fraud and detect the fraud, right at the at the juncture. So let me open up a polling question with that. We're gonna give like 30 seconds or so.
So the first polling question is, where are you in your AI ML journey? And the options are you planning to use artificial intelligence and machine learning? Have you just started off on this journey? Are you making significant progress and you're, let's say, halfway through or most of the way through? And then the last one is you have a fairly sophisticated fraud prevention program where your artificial intelligence and machine learning capabilities are already in production. So these are the four options. We'll give, I guess, another few seconds, and then we will close the polling question. So folks, again, the polling question is going to be on the right-hand side of the WebEx session. And we are asking, where are you in your AI and machine learning journey? With the four options: planning to use, just started off, made significant progress, or embedded in production.
Okay. So moving on, I'm just going to talk a little bit about the AI and the knowledge graph, what exactly they mean, and how they can be leveraged for the fraud detection purpose. So as we know, like I mean, it's really obviously it's a buzzword, and everybody knows by now what exactly is AI and machine learning. So it's nothing but a program which is basically an intelligence which is programmed in the machines based on our experience, which means that we take the data and the knowledge that we have acquired over a period of time, and we try to train the program and create a model out of it so that the machine can do the prediction instead of a human. It's really to make our the whole process efficient. It's not really here to replace a human being. In fact, it's going to augment the existing knowledge of the human being, and then do a better job in terms of when it comes down to scale. So there are different type of AI/ML algorithms. At a very high level, there are three different categories, which are supervised learning, unsupervised, and reinforcement. Supervised is something, and these are very basic definition from a layman perspective. We are not going to get too technical on this, but hopefully we are able to pass across the message, and that is the goal. So supervised learning is something where you required label data for training the predictive models, which means that we you need to provide the historical data. Let's say you're trying to build a claim fraud model, so you need to provide the claims data, the policy data, and then a flag along with that, that which claims are fraudulent versus non-fraudulent. So that flag represents like a label, and that's why we call it label data. So in case of supervised algorithms, we tell the algorithm that this is the data along with the label, and then based on that, it's going to train itself and generate a model for future predictions. There could be scenarios where you may have to use the unsupervised learning, especially when, for instance, like you may be a new organization around, and you may not have enough label data. So, or there could be a scenario where you have a lot of data, but you don't have enough labels for the classes you're trying to predict. So, for instance, you may be having now fraud doesn't happen that, I mean, fraud is not happening in like double digit percentages. Typically we hope that the fraud is happening way below like 1%. So that becomes like lack of label data. So given that scenario, we can use unsupervised machine learning techniques, where you can train the model without even having a label in place and try to do anomaly detection. The third is the reinforcement learning, where we once we implement the model, then where we try to optimize this model and or the algorithm by by rewarding on the positive outcome. So every time a feedback is generated, we feed it back into the model itself. The model gets retrained, and this whole cycle where we are completing the feedback loop, that's called the reinforcement learning. So your solution can really depend upon what type of data you have, how much data you have, and what is the goal in terms of what you're trying to predict. Now, you can always do an ensemble of models, which means you can combine a supervised and unsupervised. It could be a combination, and then you can apply some kind of rule engine on the top of it to make a combined decision, rather than focus just relying on one model. So it could always be a hybrid situation. So that's the AI machine learning part. The knowledge graph is, as I mentioned, like this is being very heavily used in the space of fraud detection, especially when you want to analyze information from a connectivity perspective. So what we do is like we take the data that is available in your system and translate that into a graph structure. And the structure helps you to analyze the connections between the actors in your system. So these actors could be human beings, this could be places, this could be organization. So you build a graph out of that, and then you try to analyze how they are connected to each other and what is the influence, both positive and negative, depending upon what you are trying to predict. So that's what a knowledge graph is all about. Now, just similar to machine learning, there are various algorithms in graph world which allows you to do graph analytics on your data. And depending upon the problem you're trying to solve, you can pick one or the other. So there are four high-level categories here: the pathfinding, centrality, community detection, similarity. So pathfinding is something where you are already aware of, let's say, a suspicious actor in your data, and you would like to know how far this actor is from other actors. So you can, see. So this is going to basically give you the path from one actor to another actor, or an actor to an organization, and so on. So this is more to find out, what are the different paths and which one is the shortest path, depending upon what criteria you're looking at. Another is centrality, where you are trying to find out influential nodes. So nodes are basically, as I mentioned, it could be persons, or it could be organization or places. And then you want to see like what is the influence of a given node in a given cluster. So once you put the data in the graph structure, you can start segmenting this data, and which is nothing but clustering the data. And then once you cluster, you can try to figure out that which nodes are most influential within that network, because that is where the center of the network is, and that is where how the fraud is really kind of influencing from. Community detection is more of like finding a group of people or organizations who are involved in an organized crime, like a network crime, which is finding like groups and clusters of nodes. Similarity is another type of algorithm which allows you to identify similar nodes. So this is heavily used for entity resolution. So for example, in your data, you may have an actor, let's say like a person who's acting in multiple roles. He could be a customer, and at the same time, he could be an employee in the company in the form of an adjudicator, or claim processing or approval guy. So we can leverage the properties of these nodes, which are nothing but the attributes about the people, and try to see if there are similarities between them. So, and this is very common, when you're dealing with systems that are integrated across your organization. You may have the same person twice, one from an employee perspective, another from a customer perspective, and you may really won't know because there could be a scheme of things happening around those sets of data. There are different applications of the AI and the knowledge graph. You can use it for policy risk scoring, that is identifying the policy risk at the time of underwriting, right when the underwriting takes place. So this is more like a prevention, that a control that you're putting in place. And once once you start receiving the claims, then before you can start processing the claims, we can build a model which can help you score these claims so that they can be processed in a specific order. Again, if you see claims in isolation, that's one perspective, but there could be a network of people or organizations who could be involved in it. So we may want to also see from the perspective of fraud rings and communities. So you can also detect new patterns. That's another way to look at it. Within those patterns, then you can look for the influential entities. As I was saying, that you may find a big network, and it could be a network of customers, organizations, and locations, and we can try to see where exactly the fraud is emerging from. It could be an organization which is kind of involved in issuing false documents. It could be a customer who's playing different roles within the network, or it could be a very location driven situation where all these actors are kind of coming from the same location, like a zip code or a state or a city, and that's where the whole influence of the network is. So that is where the combination of AI and knowledge graph comes together. You leverage the power of knowledge graph, you feed into the AI model so that AI can do a better job rather than just looking at the attributes of a claim or a policy. So we are kind of feeding the relational attributes that makes your AI model more powerful in terms of its predictability. Finally, we can also use for fraud investigation purpose, which is, you can integrate this knowledge graph, which is a more of a visual analytics into your fraud investigation system, so that the investigator can, really see how these entities are connected to each other. And we have an example, we'll go over that. So coming down in terms of the data itself, what kind of data we use when we are trying to build a fraud detection model using AI and machine learning. So you can use a combination of both internal and external data. So this really comes down to your enterprise data strategy, where you want to make sure that you integrate both the worlds together to generate a value out of it. So in terms of internal data, you can use your insured data like the demographics information, the policy information in terms of which product it is and what is the term of the policy, etc. You can also leverage the beneficiary information. We have the claim information in terms of are there any prior claims on the insured, or how many claims are being raised under that specific agent, and so on. We can also leverage some unstructured data available within the organization, like call center logs, the online portal visits, and agent chat logs. So the power of AI can also help you to generate features out of the unstructured data and then mix them with your structured data to create a better model out of it.
So I just want to mention to folks, you do have the ability to ask us questions in the chat box. We're going to get to all the questions towards the end of this webcast. So certainly feel free to ask those, and we are monitoring the questions as they come in, and then we're going to get to all of them towards the end of the webcast. And then with that, we're going to ask another question, a polling question. So the question is, how are your fraud, artificial intelligence, and machine learning capabilities developed? And the options are, these are developed homegrown, and there's an in-house development of these. The second option is you utilize off-the-shelf vendor products for the purposes of AI and ML capabilities. The third option is a combination of both homegrown and vendor products. And then the fourth option is D, not applicable, which just means that you haven't started the implementation of AI ML in your fraud programs yet, but you plan to at some point in the future. So A, homegrown in-house development, B, using vendor products, C, a combination of both, and D is not applicable, meaning you haven't started to utilize these capabilities yet. So we'll give you another few seconds before we close the polling question.
Okay, so moving on. This is how a knowledge graph looks. So what we do is like, we take the structured data, as I was talking about, your policy data, claims data, employee data, manager information, all the data that we are kind of identified in the previous slide. And then we restructure that data in the form of a graph where we build nodes and edges. Nodes are basically, and this is more of a modeling and a design skill where you try to create the nodes which are of importance to you from an analysis perspective, and then try to analyze the relationship between the nodes. So for example, here we have a node for the insured, which is connected to a policy, which means an insured is for a policy and the policy has a beneficiary. The policy is being underwritten by an underwriter. It is issued through an agent, and so on. So, and it is also connected to a claim. And if there are any remarks, you can also create those remarks on the top of the claim, whether it's a fraudulent claim or a non-fraudulent claim. So, based upon the goal we are trying to, the model that we want to build, based on that, we kind of model the knowledge graph and then feed your data into the knowledge graph so that we can analyze, run the algorithms and generate predictions out of it. And the predictions of the knowledge graph, we feed it back into the AI model as I was talking about. So I'll show you an end-to-end architecture, an AI-enabled architecture, how it is being implemented in the industry. And this is what exactly we do for our clients too. So there are source system, which is, and this diagram moves from left to right. So we collect all the data from the source system, various source systems. So there could be more than one system, like your underwriting system, your claim processing system, maybe customer management system. So we collect all the data, bring into a repository for analysis. Then we apply the graph analytics algorithm on the top of it. We organize the data in the form of a graph. Post that, we extract features out of it. Once the features are extracted, then there is a step of feature engineering where we take the raw features that are coming from the original data, and then we also kind of enhance them by using the insight that we have received from the graph. Once the features are built, we we apply the algorithms, we generate a model out of it. And once the model is trained, then we kind of test the model on out of sample data to make sure the model, has a very good accuracy level on the data that is not seen by the model. We don't want a model to be, very biased to the data. So we kind of take a slice of the data of the total data, and then we train the model based on that. And then once the model is trained, as I said, the leftover data is for testing purpose. Once the model is created, then the model is implemented into your underwriting system as well as the investigation system. So the underwriting system, this is more from a control perspective, like being more proactive, where we try to kind of, try to prevent the fraud right at the beginning during the underwriting phase, and see how risky is this policy or what are the chances of receiving an early claim on this particular policy. Based on the feedback from the underwriter, we take that back into our system. We retrain the model on a periodic basis, and that is where the reinforcement comes in. This kind of helps you to keep your model up to date in real time, and prevent any further fraud and make better decisions. We create also a model that goes into your investigation system so that we can score your claims and they can be prioritized. And also we kind of leverage the power of graph in your investigation system. This will help the investigator not only to understand the priority or the seriousness of the claim, but also try to analyze, when they are trying to investigate the claim itself, that how this claim is connected to other claims and the other actors within your ecosystem, so that they can make a more informed decision, on the claim itself. Okay, with that, we'll move into a demo and then we'll do a final Q&A post demo. So we'll probably spend another 15 minutes on the demo and then get back to Q&A session.
Noticing the chat for questions, and one of the questions that we got in the meantime, I'll look at that one, is, so the participant is asking, how do we start on the journey of utilizing AI or machine learning type of techniques in the fraud investigation and the fraud program? And so I guess the gist of the question is that the participant is asking, where should they start from? So I'll provide my answer in terms of my experience in building these types of techniques in various financial services organizations. One of the ways to build these is to really start off with proof is in the pudding approach. So start small, do some proof of concepts, start off with one region or one system. And then as you apply these AI and machine learning techniques, you're going to start to see the power of these emerging technologies in identifying fraud and then, more importantly, preventing fraud. So start small, do a lot of proof of concepts, establish ROI, find supporters in senior management who, as they see the result of these techniques, are going to start to become more and more believers, and that's how you find investment as well. And that's how you then start to build scale in deploying these at a larger organizational level across the whole organization. So that be my response to that question. In terms of how do you start, I would say start with a limited scope and start small, and then build from there.
Okay. Thank you, Arslan. So I hope you guys can see my screen. So this is I have logged in into the claim fraud analytics application right now. On the left, you can see there are various modules that are available. So at a very high level, this platform has two major components. One is the data management, another is analytics. The data management component starts with data ingestion, which allows you to pull the data from disparate systems and perform a data quality checks, profile your data, because you want to make sure that the data quality is good before you can start analyzing. Otherwise, it's going to be garbage in, garbage out. So this has enough capability to bring your data, massage your data, prepare it for a variety of analytics. Right now, what you see is all the data that is exposed to the platform. So there is no data that is physically copied on the platform. But what we are doing is we are connected to a warehouse where all the data has been brought in your enterprise data lake, and then we can start looking at the data, analyze the data, and build models around it. So I'm going to pick one of the data set here called claim features data set. This data set was built primarily to build the AI model. So what we do is we take your raw data and we apply the domain, the business knowledge to it, and then create features out of it. Features are nothing but inputs to the model, which helps the model to train itself and generate a prediction out of it. Now, I'm talking specifically about the supervised model here. So in this particular data set, we have a variety of, there are many columns here, approximately 75 features we have created. This is ranging all the way from the demographics data, the policy information, the underwriting information, the claims data, and so on. So these are primarily the claims that are happened in the history, in the historical claims, basically. And all of these claims have been marked as, whether they are fraudulent or non-fraudulent. So this is referring back to the discussion of label data. You can quickly glance through some of the sample data that is available in this table or in this data set. Trying to see what's out there. For some reason, my internet is really slow today. Let's see.
And Yogesh, as this loads up, I want to take care of as many questions as we can, just so we don't have to wait till the end. So one of the other questions we got from the participant is, what have you seen as one of the biggest challenges in implementing AI or ML for fraud detection? So based on the work that the company has done in assisting other clients, what are some of those big challenges that our attendees need to be aware of as they think about starting off?
I think one of the biggest challenge I have realized is, obviously, there are many tools out there and the platforms out there which can cover the skill gap. So skill gap is one of the issue, but I'm not going to make it sound like a major issue, because then we have these platforms and tools which can increase your productivity of existing analysts who are coming from the traditional world, but kind of leverage the power of AI. I would say the focus should really be to have the right tools and platforms within the organization which can help you bring the data from a variety of sources, because traditionally the tools and platform that are accessible to the analyst is mainly for the structured data. So I think having a tool under your belt which can help you process both structured and unstructured. And when I say unstructured, it is dealing all the way from textual data to images and videos, because a lot of companies, they've also been leveraging videos from a claim perspective, especially in the space of auto claims. Once you have these tools with you, and if the data is, you are able to collect the data and harmonize the data, then the rest is just applying the machine learning algorithms to build a model. Yeah. So coming back to the demo here, so this was the sample data I was talking about. I can quickly kind of look at how this data is distributed on the age column, and there are many other columns, but this is just to take a quick glance on the data itself. So data preparation is a package where we kind of prepare the data, and the data science is the place where you can go and explore all the existing algorithms and then build a model. So out of the box, there are around 35 to 40 algorithms that are available, and they go all the way from basic regression to classification to recommendation engine, neural networks, and even if you want to do like text processing. So we have all sorts of algorithms available. We also have algorithms which allows you to extract data out of PDF, because there are many companies who are not fully digital and they may still have a lot of data that is being collected in the form of soft documents, and then we can extract this data, we can process it and generate features out of it. So I think that is where the differentiation comes while building a model. I mean, everybody starts with like the raw data, which is like easily accessible in the form of in the structured form. But when you really mix up the structured and the unstructured, because a lot of information is also valuable in the unstructured, that's when it's a game changer. Again, you need the right tools and technologies to make all this happen. So here what I'm doing is, as you saw those algorithms, I'm going to show you how to create a model using the platform. So here you can just put all the basic information. You can decide which library you want to use. We use all of the open source Python libraries to build your AI models. You can choose the algorithm of interest. You can decide what is your label. Label is nothing but what you're trying to predict. So in this particular case, we are trying to predict the fraudulent claims, and then all the features, which is nothing but the inputs that are going to feed into the model. So as you see here, we have a bunch of inputs. We have almost like 73 features. Now these features are, this is not like, the tool cannot do a magic. This is where we need the business knowledge from the analyst. We talk to the business, we understand how the business works, what are the important parameters, and then we pick and choose. And we also kind of derive new attributes out of existing attributes, like ratios and aggregated values, etc. So you can pick, you can decide which features you want to use. You can encode them, and there are a few technical things here which allows you to impute the data so that it can be consumed by the model, by the algorithm to generate a model out of it. Okay. So once you build the model, then we can train the model, and then finally, once you train the model, we can look at the results. So when you want to train the model, this is where you will, point the model to the algorithm to the data, which will create a model for you. So in this particular case, I have created a model here. This model is going to, and this is where the data is going to come from. This is the same data that we saw a few minutes ago. You need to point to where is the label column. Label is where you are kind of marking a fraudulent versus non-fraudulent claims, and these are all the features that were a part of the model, which are being mapped to the data, to the columns in your data, to the attributes in your data. Once you map the data to the algorithm, then you are going to pick few other things there, whether you want to save these features in your output, you want to calculate the feature weights, where you want to save your results in a flat file, or you want to save into a database so that then you can build dashboards and things like that for consumption purpose. And then you can decide what is the train and the validation percentage split. So 80% of the data will be used for training, and 20% will be the out of sample data, which will be used to validate your model. How good is your model on the data that is not seen by the model? If your data volumes are very low, then we can use some sampling techniques, which allows you to upsample your data, and then allows the algorithm to do a better job. Okay. So this is where you configure, this is the training configuration for the model itself. And once the model is created, then you can go to the results area. I can, open that particular train execution, and we can look at what algorithm was being used. So in this case, we are using a gradient boost tree. It's a Python-based algorithm. It has got around 73 features. This is a set of sample data that I provided, how long it took, and all the parameters that went into creation of the model. Okay, so the platform allows you to do all of this, perform all of these steps without writing any line of code, yeah, and you can quickly build multiple models, and then kind of do a comparison to see which model is the best model, and then you can finally deploy the model. So the whole journey of data science on the platform is from creation of the model, testing the model, evaluating the model, and then finally deploying all the way till the production. Okay. It will show you all the feature importances. These are again the results coming out of the model, which tells you that which feature is more important, because you have like 70 to 73 features, but how do you know what is actually driving the model? So the feature importance will tell you exactly which feature is more important than the other one. It's basically like, telling you the significance of the features. Now that doesn't mean that every prediction that we are making is going to be based on this, because then you could have just created a rule out of it. That's not how it works. This is a more generalized view on the model, and then you have something called feature weights, which will allow you to see what is really driving a particular prediction out of a set of predictions. Here we can look at the performance of the model. What is accuracy? It's a 77% accuracy. How many records were there? So in this particular case, we were having 1,000 records. We did a split of 80-20, where 20% of the data was set aside for testing purpose. So those are the 200 records which were set aside for the testing purpose, and these are the prediction that has been made. So the actual, in this particular case, if you see, there were 151 actual non-fraud which were predicted correctly, and 4 were predicted incorrectly, and so on. So the green represents the correct prediction, the red represents the incorrect prediction. No model is going to be perfect. So and obviously, if you come across in your journey of AI, if you create a model which is like 100% accurate, like you better find it very suspicious, because that's not the normal in when you're building the AI models. I would say if you're getting an accuracy anywhere in the range of 60 to 80%, that's what you should aim for. You can look at the train and the test data that was used as a part of this execution. Let me take you to the feature weights. So for auditability purpose, if you want to save the data that was used for building the model, then you can look at the train and the test data. That's more for audit purpose. And then we can look at the individual predictions here. So I can choose a particular claim, and then it will tell me what exactly was predicted. So in this case, a prediction of 0 was made. 0 represents a non-fraudulent claim. 1 represents a fraudulent claim. And then it will exactly tell you what features are really contributing to that particular prediction. So everything on the right you see here, the orange is representing towards a fraudulent claim. Everything on the left is for non-fraudulent. So I can pick, let's say, top 30 rather than all. And you can see that the top 30 factors which really contributed here. So for example, the claim requested amount, this was having a weightage of 0.04% in making this prediction. So this particular feature weight idea would help you to identify how a prediction is being made and where we need to focus on, because merely giving a prediction to an analyst saying that this claim is fraudulent is not enough. We need to back it up with some kind of highlights, or some kind of reasoning that what exactly is driving the predictions. So what I'm trying to say is AI is not necessarily a black box. It just depends. I think it has evolved a lot in the last couple of years, where it can not only predict for you but also tell you the reasons behind the predictions. Okay. Moving on. So what the next step is really to take the outcome of this model, apply some kind of rule engine, because you're not going to be 100% dependent on just the AI model. So what you can do is you can mix and match different factors. You can take the factor. One of the factor could be the prediction of the AI model. Another factor could be more traditional in nature, where you are saying any claim that is coming out of a certain region or geography, or it could be a combination of like any claim amount which is beyond a certain amount, and you can mix and match, and you can create a business rule out of it. So we also have a business rule engine concept on the platform, which allows you to create a rule based on your business knowledge. So here what I'm doing is I'm pointing to the predictions that were made as a part of the AI model, and then I can apply some filters. So you may want to say that exclude all the claims that came from a certain region, because that's not a high risk geography, and things like that. So you can exclude some noise out of your data, and then you can only focus on the claim that you're interested in. So in this particular case, this is just an example or an example of a business rule where I am generating some scores on each of the claims. So I'm considering the claim amount. If it's greater than 35,000 USD dollars, then assign a score of 100 with a weight of 50%. And also I'm considering the probability of fraud, which was predicted by my AI model, and assigning a similar way a score of it. So eventually what we are trying to do is we are trying to create a weighted average score on each claim, and then higher the score, we give a higher priority to that claim for further processing. Okay, so using an AI model doesn't mean that you have to throw out your business rule engine. I think it is all about enabling the business rule engine to do a much better job. But again, you are going to rely heavily on the AI model from a probability perspective, and then kind of enhance your existing rules as well. Once you configure the rule and you execute the rule, then we can generate alerts. This is basically like applying thresholds on your scores. So we can say that all the claims which are greater than score of 50 out of 100, please generate an alert on them. And then we also have a case management system which allows you to triage those alerts in the form of cases. So ideally, you can have more than one rule, and you can combine this rule to generate an alert, and then you can have multiple alerts, which can then be further combined to identify a case. So I'm going to take a top-down approach here, where I'm looking into a case. So these are all the cases generated on the claims. This is a claim which has got a score of 100, which has got a very high score. It's a severity high. I can look at the entity details on this particular claim, like what are the claim attributes, amounts, when was the claim raised, and so on. I can look at all the alerts that were generated as a part of this claim. Now, we can drill down into this alert right from here, and then we can see, like what is the information about. So this particular alert was generated on a claim. Again, you're looking at the claim information. You can see which rules were fired as a part of this particular alert, and you can further drill down into it. So this case management dashboard will help you to triage the alert that is generated, not just like knowing that there is an alert, but also help you to see all the supplementary information around the alert, both in terms of the claim information, policy information, and then also do like a link analysis, which kind of allows you to uh, you know which allows you to connect these entities all together. So Arsenal, I'm going to move into an alert generation example. In the meantime, maybe you want to take another question.
Yep. So let me look at our chat. Okay, so I see another question. Our technology environment consists of many legacy technologies and disparate systems. Can we still implement this type of architecture? So I guess I'll take this one. I think having a technology environment that consists of legacy technologies and disparate systems is probably the norm. I can count maybe on one hand organizations that don't have legacy technologies. Pretty much all of the ones that I've ever worked on have that. So it's a common problem. At the end of the day, companies acquire other companies, and then through those acquisitions, you have many different systems that are band-aided together. So again, that's a norm, not a problem. I would go back to my original point. I would say prioritize where you want to start from by looking to see if you can establish and credentialize the power of ROI and and the use of machine learning and AI. So I would say if you have, let's say, 10 different claims processing systems, start with the one that is meant to stay, and the others may end up getting retired in the future. So start with the one that's going to stay. Start with the one that gets a reasonable number of traffic in terms of data flow and the records that are on it, because these machine learning and AI algorithms are data hogs. They do require a ton of data to build these algorithms. So start small, start with one system, on the claim side, one on the underwriting side, and then as you establish the power of these and the value of these, you fine tune them, and then you scale them up and then expand it out to the organization. That's how I'd approach the environment where you have legacy technology and disparate systems.
Thank you, Arslan. So moving on, I think we're in the final 8 minutes. This is how this is one of the dashboard that we have created. So on the platform, once you generate all the results, you triage the cases. Now, based on the feedback, we can take all of this information and build a dashboard out of it, so that it can be then presented to your upper management. Where what we are trying to build is like a dashboard which contains how many claims were requested in terms of the amount, how much amount has already been settled. We can see the distribution of the claim itself by region, by age, by collection frequency. And then we can also look at all the predictions that were made by the AI model, the fraudulent versus non-fraudulent. So as you can see here, 76% of the claims were marked as non-fraudulent. Obviously, you don't want every claim to be marked as a fraudulent claim, because then the model is not doing a good job. It is completely skewed or too biased. You can also see the distribution here in terms of the prediction. So this is the actual, again, this is the mock-up data. So as you see here, 24% of the claims is marked as fraud in the actual data, and this is what the model has predicted for us. In terms of the knowledge graph, so what we do is, through the platform, we feed the data into the graph database. We use Neo4j as one of the graph database, which is a very popular database, very powerful database. And in this particular case, there are three different claims. So we have modeled the graph using Neo4j, and now I should be able to kind of navigate into this. So I can say I want to expand this and find out this claim was adjudicated by which adjudicator. So you can see in this case, this is adjudicated by Herman Bullock, and then I can keep expanding this in terms of you know like phone numbers and things like that. So this we have model where it's telling me what is the phone number that belongs to Herman, and I can also try to see if this phone number belongs to anyone else. So it looks like there is one other person to whom this phone number belongs, Tom Riggs, and Tom Riggs is, let's see, who is he? He's a beneficiary of one of the claim, and we can try to see if uh, who's actually benefiting, to which policy it belongs. So there are two other policies in our data, which is where Tom Riggs is the beneficiary, and Tom Riggs is actually sharing a phone with Herman Bullock. So that seems to be an anomaly, because how can two people have the same phone number? I mean, this could be some typo while entering to the system, or it could be a real thing. So what we do is, like, a lot of times these actors, what they do is, like, they flip the phone numbers, like out of the 10 digits, they would just flip like one or two digits. And we run these algorithms to identify that these two actors are actually the same actors. So in this case, this seems to be very suspicious, where a beneficiary from another policy is also sharing the phone number with an adjudicator from another claim. Let's see this claim belongs to which policy. Okay. So apparently, if you see here, it belongs to the same policy. So this is kind of very weird, where you have the two people sharing the same phone number. So these are the kind of anomalies we kind of discover out of knowledge graph, and then we take this information, we score all of these nodes, which are nothing but the individuals, and we apply those scores into the AI model, which then kind of helps us to do a better prediction. Okay. So I'm going to go back to our next steps. So Arsen, you want to take it from here?
Yeah, so I'll talk about the next steps, and also we have another polling question that I'll get to. So in terms of next steps, we hope that you enjoyed the webcast. It was knowledgeable to you, and some of the capabilities that we demoed to you today. We'd like to offer you a proof of concept. We're trying to see if this is something that will help you. And again, being that data and AI and machine learning evangelist in your organization, by trying to bring in that forward thinking, and we're happy to help you and partner in doing so. So we're looking to do a proof of concept with you. If you have interest in it, the goal is to really provide recommendations for strengthening the fraud program by utilizing these emerging technologies. What we will deliver to you in those 4 to 6 weeks would be the insights from applying artificial intelligence and machine learning on your actual data. So that's something that we'll do. And then the duration is really meant to be 4 to 6 weeks long. There is no cost to you. And if you have interest, certainly feel free to reach out to us at our email address, contact us at inferyx.com. So that's something that we're happy to offer up and do this with you in partnership with you. So that's that. And looking at our polling questions, I do see one last question. What kind of skill sets are required to use your platform? So that's something that, Yogesh, if you don't mind taking up that one.
Yeah, I'm going to quickly.
All right, so we'll get to that question as well. And then the polling question up front is, what type of fraud controls are embedded in your process flow? So is it underwriting, that's where your fraud controls are embedded, or while claims processing, or in both? So if you can answer that, that'd be great. And then in the meantime, the question that we got from the chat environment is, what kind of skill sets are required to use your platform? So I know, Yogesh, you were just walking us through the point-click capabilities. So if somebody wanted to use the platform, what type of skill set would you expect them to have?
Yeah, I mean, good question. So I think, in the absence of the platform, obviously you have to be super technical. But I think with once we start using the platform, the Inferyx platform that we have built, you need to be an expert at understanding your business problem well. You have to be more of a domain guy. where where IT and business can really partner together. So IT can use the platform to bring in the data from various sources and integrate the data, make it available to the business users, and then the business users can go and explore the data, build the dashboards, build the AI models without writing any line of code, without getting in the nuances of technology, and keeping obviously the auditability, the scalability, all the other aspects in mind. So this could be a one-stop solution, which can include both IT and business to collaborate and kind of manage the ecosystem and build models that can really benefit the business.
That's great.
Yes.
All right. Looks like we're almost at the end of the hour. And if you have any further questions, I do see a few more questions, but I don't see, I don't think we have the time for those. So certainly email us those questions. Happy to go through them. And then the last one, the polling question that we have here is really, are you interested in the 4 to 6 weeks proof of concept? So certainly let us know. The answers are yes. Hopefully a lot of them are yes. And I do see that yes spiking up. And then nobody has said no, which is excellent. And then the last one is ask me in 3 months, which really means that you need some time to kind of think about it. So that's that. Again, thank you very much for your time. We have the contact information up on the slide. Feel free to reach out to us if you have any follow-up questions.
Yeah. Thank you, Arslan. Back to you, Sarah.
Yeah, thank you everyone for joining today's webinar. If you have any questions in the meantime, please reach us at the below mentioned email ID and number. Thank you.
Thank you. Bye.
Thanks, folks.
Bye.